functions and their derivatives. Yeah.
Do they have the trigonometric identities
Do they have the, you mean like in the front cover or something?
I hope not.
Yeah.
and
Should.
basic ones?
Yeah. Yeah, inside flat front cover. All right, so with these 6, we can now tackle all sorts of functions we could not before. Anything that involves a trig function, we can now take the derivative of. So let's try it. Number 20. You guys do have calculators when you take your exams, so I guess it's not terribly important for the exam to know the special angles and their trig function values. But if you're going to go on to any higher level mathematics, it's a really good idea if you memorize those. Just makes everything efficient. Yeah, because you know, you can, if they give you a special angle, you can figure out faster in your head than you can punch in a calculator anyway. You know what I'm saying? If you just know them. But whatever.
As long as it falls in between the angles, do you see what I mean?
You should know.
Yeah, that's
Those. You should know those angles in these 3 functions. And you can easily figure out these 3 from those 3. Matter of fact, you really just need these 2 to figure out these. Matter of fact, you really just need this one to figure out this one, which gives you that one. Right? If you know how to think through it properly. Right? But, you know, in this class, you got a calculator, so it's no big deal. So it's up to you how much you remember from pre-calc regarding this particular topic. But it does make certain problems a lot faster if you just know it. All right, so let's try a derivative now. We said number 20. It doesn't play into every problem. We're just finding a derivative right now. We're not trying to find the value of the slope. We're not going to have to plug anything in this problem right now. Okay? So it's not going to come into play immediately. Y equals x squared minus 1 x squared minus 1 times sine x over sine x plus 1. Alright, there's the function they give us, and it just says find the derivative. That's all we have to do, find the derivative. So it's going to employ a lot of the rules we have. It's going to employ a product rule, because there's a product above. It's going to employ a quotient, because there is a quotient here. It's going to employ a sum, because we have a sum right here. It's going to employ a difference, because there's a difference here. And it's going to employ trig functions. It's got almost everything sitting in there. So be very careful with it when you're mixing these all together. All right, so the most outer thing happening is presumably the quotient part. So the first thing we're going to do is attack it through a quotient rule. Okay? I'm going to use intermediate notation now when applying the quotient rule. There'll be a d dx is floating around in this expression I'm going to write. Okay? So I'll find y prime, or dy dx, equals, as a quotient rule, it should be the bottom, sine x plus 1 times derivative of the top. So I'm going to write that in notation. I need to take d dx of the top. Top is x squared minus 1 sine x. Because you may not be able to take the derivative in your mind in every single situation. Maybe too complicated, right? This is going to require a product rule here. So just to knock that out immediately and slap this in here, you may not be able to do right now, okay? Or ever. Depends on how complicated the problem is. So I'm going to write this intermediate thing we need to do. I need to take d dx for the quotient rule, okay? Minus top x squared minus 1 sine x times the derivative of the bottom. Now this is a little bit easier. Maybe you can take the derivative of the bottom in your mind very quickly. It's just cos, right? But I'm going to write it just like I wrote this other one. I need to take d dx of sine x plus 1. Okay? That is the numerator of the quotient rule. Everybody agree with me? You said I'm writing or not? Thumbs. Ray's got thumbs up. All right, I'm moving it. All right, bottom. Square the bottom. Sine x plus 1 quantity squared. I mentioned this goof up the other day that sometimes people do And now it's more likely it will happen when using this notation. Well, look, I see a sine x plus 1 here in that term. I see a sine x plus 1 in this term. And there's a sine x plus 1 down in this term. To make this whole process a lot easier, I will cancel the sine x plus 1 from every single term. Why can I not do that?
Because it's minus.
This guy?
Yeah.
No.
There's a d.
Because what?
D over dx.
Because this has a derivative applied to it. This little guy here is not sine x plus 1.
Yeah.
This thing is the derivative of sine x plus 1, which I have not computed yet. So this is not a factor of sine x plus 1 sitting here, right? It's the expression for the derivative that I need to compute. So I cannot just factor sine x plus 1 from everything. This is not a factor of sine x plus 1. Okay? So don't get quick to start canceling things. What do we need to do now? We need to compute x squared minus 1 times sine x, the derivative of that. So that's going to require a product rule. So now you have a choice. You can take that little bit of work off to the side and then slap it in a second. Or you can write another full set of all this material with the expression for the product rule in there. What do you want to do? Side work? Side work? All right. You guys are smarter than some people I've met. All right. So, dx, x squared minus 1. You're smarter than me, apparently, because I always just did it the long way. Whatever. All right. X squared minus 1 sine x. So, that should be the first times the derivative of the second. Okay, here it's getting a little bit easier now, right? So, what's the derivative of the second? No. Derivative of the second. What's the second? Cos, right? Okay. It's getting a little bit easier, so I'll go ahead and write that without the extra notation. Plus the second, which is sine x, times the derivative of the first, which you said is?
2x.
Okay. So we got that. I now need to insert that expression in here with a bracket around the whole thing. Okay? This get pretty messy. As long as you're careful, as long as you're a good bookkeeper, there's no problem here, right? I think derivatives is easy if you're good at bookkeeping, you're good at accounting. Who's an accountant in here? Who's my accountant? Any accountants? Yeah, they take business calc, right? They don't take real calc. Okay. So let's insert that piece into here.
Wait, why can't we do the other one and then insert it all?
Which one? This one over here?
Yeah.
No, we know that one already. It's just costs.
Okay.
Yeah. I mean, you're right to do it that way, but I'm not
Right.
going to write it off this side because this one is getting a little bit simpler now. You can go ahead and, like, let me say eyeball it, right? Eyeball that. So sine x plus 1 times that bracketed material up there, x squared minus 1, cos x, plus, I'm going to write it in the usual order, 2x sine x. Usually write non-trigonometric functions first, right? Especially when they're like polynomials or something, right? So 2x sine x is the way I'm writing it. That was this, right? That was that material right there. All right, minus. This is fine, except for this last part, which Cornelius says is a cos x. So this will look like x squared minus 1 sine x cos x, right? Bottom's the same. I hate to even write it. Sine x plus 1 quantity squared. All right.
Why cosine x?
Because that's what this piece is here. The derivative of sine x plus 1 is that cos x right there.